Everyone, today we are going to talk about one-way ANOVA, analysis of variance. This test, we use it when we have more than two samples or categories that we want to check their means or the population means for that, like at least 3 sample means. And we do this test for checking their population means and testing the hypothesis. Let's see the hypothesis that they have. Actually, for the first one is the mu of the population means are for the 3 or the k samples are equal. The alternative hypothesis says that at least one of the samples mean is different than the others. For example, like this one is different from the others, so we take the alternative hypothesis win. So for this test we use the F test, and the F test indicates that whether or not there's any significant differences in the means between any of the groups. As I said before, the F test, when the F test significance level is 0, so it means that it's one of the means is different. So we check the significance value, which if it is less than 0.05% or more. Let's take an example about the sprint. Like in the samples dataset, the variable sprint in the respondent's time in seconds to sprint a given distance, and smoking is an indicator about whether or not the respondent smokes. So we have 3 categories. We have non-smokers, we have past smokers, and the current smokers category. So let's use ANOVA to test if there's any significant difference in the sprint time with respect to their smoking status. Sprint time will serve as the dependent variable, and the smoking status will be the independent variable or the categorical variable. Now let's go to the software using the one-way ANOVA dataset. Here we open this file, then we have the data. Alright. Now what we are going to do is go to analyze, comparing means, and then one-way ANOVA. For this we will use the sprint as a dependent variable, and the smoking for the independent the factor, which is it's going to include the non-smokers, current smokers, and past smokers. Alright, this is the resulted table. We have the sum of squares, degree of freedom, mean squares, F test, and the significance. The significance here is 0.00%, so it's 0%, and we take the alternative hypothesis, which is at least one of the means sample or one of the means population is different than the others. But here we don't know which one is different than the other from the others. Let's go and check by checking some more options. If we go back, analyze, compare means one-way ANOVA, then we check the post hoc. Alright, this one we have 2 options here. Equal variance is assumed, and we have the equal variance is not assumed. We check this one. Also we can go to check the variance, so we can add the descriptives also, the homogeneity of variable test. This we can check if it is if it's there's a variance is equal or not among the groups. This test can give us that. and we can also draw the means plot. Alright, now everything is okay. We have the descriptives here, number of observations for each, number of participants. We have 261 non-smoker, most of them are healthy. So the rest, past smoker 33 and 59. For the current smokers, the mean, standard deviation, standard error, the confidence for each group, the minimum, maximum. Alright, here's the test of homogeneity of variance. Here we have it, it's 0.09, and it's, for this it is more than 0.05, which is assumed that the null hypothesis says that the variances are equal, and the alternative hypothesis said that the variances are different, are not equal. So for the alternative, we use the word different. Whenever we see 0.09 0.00, it means different. That means we are taking the alternative hypothesis for most of the tests, not all of them. So here we have it more than 0.05, so it's not different, it is similar. So the variances are equal of variances is assumed. Now for the ANOVA, this is the same as we explained. This is 0.000, and it gives us that one of the means is different from the others. This is the post hoc test. This one shows us that we can check here the differences. It check the difference, that's if there are any significant differences between each two groups. So non-smokers, past smokers, the significance is 0.165. It means they are there's no differences. Here we have they are different, the means are different between this non-smoker and current smoker because it's 0.00. So there's difference here and difference here between the current and non-smokers. It's the same. This one is the same as this one, and the rest are or have statistically equal means. Alright, so for this homogeneous subsets, so it gives us we have two subsets, the first subset, the second subset. So the first subset is telling us the non-smoker and past smokers are in the same subset, so they are equal, or there's no differences between these two categories. And the second subset, there's no differences between these two categories, between these two. So this is the second subset, this is the first subset, but where is the differences here? If you can see, this is differences between this one and this one. They are not together, they are not in the same subset. This one and this one, they are not, they are different. Like as we see here, the current and the non-smokers, there are differences in their means population. Here's the mean plots. We can see this is it's easy for three groups, but when we have more than that, so it gives us a good view about the means. So we have, there's differences between this one and this one, the non-smokers and the current smokers, there's big difference, but the difference between the past smokers and current smokers is not significantly different, and also here's is not big difference. This is all for today. Thank you so much for watching. See you in the next video.